for the welcome. So as mentioned, my name is Rob. I'm a senior developer advocate at HashiCorp, mainly focused on the secure product line. In this case, we're going to be talking about one of our secure products, which is Vault. But let's talk a little bit about zero trust before we get into anything, right? So zero trust has kind of become this buzzword in the industry. I mean, maybe the fact I included zero trust in my proposal for this talk is the reason why it was accepted. Who knows, right? But it's so much more than that. You know, companies are using it for SEO, but what does it really mean? So I don't know if the slide's actually changing. Is it changing? I don't think it is. There we go. There we go. So the first time I came across the term zero trust was when I was reading a series of white papers published by Google. They have this initiative called Beyond Corp. Essentially, what they were trying to do was reimagine the current enterprise security models to allow more of the Googlers to work remotely from different locations, whether it was untrusted networks, hotel Wi-Fi's, and connecting into their networks and so on and so forth. And the way that we understood the problems with the initial network perimeters is, you know, we had this theory that we have like a castle and moat kind of approach, and we trust anything that's within the perimeter, and anything that's outside the perimeter is deemed as dangerous, right? What Google understood is that that model had some flaws and was becoming problematic and harder for us to enforce. Why was it becoming harder? Well, you know, a lot of our enterprise applications were now moving to cloud-based offerings, and the perimeter is not so clear. If you're hybrid, for example, you've got your data center and you've got some workloads in the data center, and then you've got some other workloads which are in one of the big clouds, for example. You now have this thing called the shared responsibility model, and what exactly are you enforcing? So essentially, Google set about this initiative to try and figure out how can we change this paradigm to help us enable our people to deliver more productivity, right? So essentially, what we were doing before is we were trusting everything inside the perimeter and nothing outside of it. And what we're saying now is we trust nothing, right? Whether you're inside, whether you're outside, we trust nothing, right? Zero trust takes a different approach. So the assumption that zero trust makes is that your perimeters, your networks, it's already been breached, right? So if the attacker's inside, what would you do, right? And that's the whole point about verifying everything. So if you feel that your network has been breached and the attacker's inside and the attacker attempts to perform an action, wouldn't you want to verify who they are and if they're allowed to do those things, right? And it's actually crazy to me to think that previously we didn't have this kind of approach. It was just if you're inside a network, you can do anything you want, right? So that was the biggest flaw with how things were done, is as an attacker, once you've breached that perimeter, you've pretty much got unrestricted access to everything. So we trust nothing, we verify everything. And before any action can be performed, we need to establish two principal things. So the first thing we need to establish is who or what is trying to perform the action. So the who or what, that could be a human, like all of us in here. It could be an application, a machine, a system, a platform, any of these things, so a workload or a human principle. So you need to establish what that is. And secondly, you need to establish, are they authorized to perform that action, right? So when we think about how we're going to verify these things here, the core construct here when we talk about zero trust is identity, right? Everything is about identity. Like I said, it can be a person, a machine, an application. And when we talk about verifying identity, essentially what we're talking about is authentication, or auth-n, right? And we do this by providing a unique piece of information that identifies us. So as humans, we're all pretty familiar with the systems in place. We have passwords, we have multi-factor systems to add extra protection, and so on and so forth. When we provide these pieces of unique information, that is us attesting to whatever the target platform is that we are who we say we are, right? For applications, it may be something like an X509 certificate or some other kind of identification piece of material. But that's the point, is we want to verify the identity before anything, and we need to do that with a unique piece of information. So once we've verified the identity, we can then verify authorization. So we know who you are. Are you allowed to perform this action? And then we can go across our rule base and see what permissions does this person have, right? So how does this look in a practical example? Now, this is designed to be a very simplistic representation of an application. So, I'm pretty sure your applications are a lot more sophisticated and robust than this. But this is just to demonstrate something, right? So we have the client side of the application, which generally speaking is what our users and anyone that's supposed to interact with the application will use, right? Then you have the server side, which contains your business logic and application logic. And then you have the data layer, which will be either your customer data or your application data or whatever it is that's associated with your system or your platform, right? But for a lot of organizations, when we talk about business value, what they're really talking about in this simplistic example is that data layer, right? That is the core of their business value. If they were to lose that data, if something was to happen to that data, it potentially could put them out of business, right? So this is the thing that they need to protect, right? It doesn't mean that the other layers are not important and we don't need to take any steps, but they merely act as an attack surface for the real prize, which is the data, right? So what are the threats to the data? So when we think about protecting our data and the things we need to protect it against, the first thing we need to do is protect the confidentiality of it, right? So if we have personal identifiable information in our data, if we have customer data or things like credit card numbers and social security numbers, right? So these are things that we may deem as sensitive and we need to protect its confidentiality. And how we go about doing that is it normally starts with a data classification strategy. We've all seen the spy movies and the James Bonds where you see a document that says top secret or highly classified or eyes only and all these kind of really cool phrases. These are essentially data classification strategies just in action in the movies, right? So we need to implement our own strategies which work for our business structure, our business posture, in order for this to work for us, right? And what that does is it informs us which pieces of data in our systems that we deem as the most sensitive. And with that information, we can take the steps to protect it. The next thing we need to protect is the availability. So we've talked about confidentiality. And that's all good. You've got your data, it's nice and confidential, you understand what is sensitive in that, and you've taken the steps to protect it. But it's no good to you if you can't access it when you need to access it. So if your customers need to access their data and they're authorized to do so, if your systems or applications need to access the data and they're authorized to do so, it's not really any value to them if they can't, right? So some of the most high-profile attacks that we've seen in recent years are not actually attacking the data itself, but it's actually denying us access to that data. So when we think about DDoS attacks or denial of service attacks, essentially they're bringing down systems and we no longer have access to our data until we can restore that. So we need to protect the availability of our data as well. And then we have integrity, right? So integrity is also another important point. Integrity is all about ensuring that no unauthorized manipulation has occurred to our data. Whether that was via a malicious actor or whether it was by mistake or anything like that. And a practical example of this is, banks have gone through digital transformation like a lot of the world's industries have, and now all of our banking is digital. And the bank data says that in this bank account there is £1,000, right? But if a malicious actor is able to manipulate that data and say that, no, it's not £1,000, actually it's £1 million, right? Just so that they have the ability to withdraw money that they don't really have, well, we can no longer trust the integrity of that data. So this is another thing that we need to protect, right? So essentially, those three things I've described are the main pillars of cybersecurity. So if you look at the way that I've drawn this diagram, I've done it very specifically like this. I've made it look like a house or a building, right? I believe if I didn't work in software, I probably would work in architecture because these are some of the things I love. And you can make a lot of direct comparisons between architecture in a building sense and this example here, right? So if we look at data, we've got data at the top and that's in the shape of a roof. Over here in the UK, we have this saying where we say, as long as you've got a roof over your head. And what we're implying by that is that the core value of our home is to keep a roof over our head, give us that shelter, right? The data is the same thing to a business, right? It's the core value, right? Holding up that roof, or the core business value in that sense, are these pillars that we've just discussed. So if we translate it back to the building analogy, these pillars act as our bricks and our mortar, right? This is what's holding up the roof. If any of these pillars fail, our roof can come down. It may be compromised, it may fail, right? So it's very important that we understand the kind of the relationship between these pillars and the data. And then you can't just build walls, right? You don't just start putting blocks and then putting cement and building them up. You actually have to build foundations, right? You have to dig into the ground, you have to give it a solid foundation so that it will stay up, right? And in this analogy, zero trust, or the approach of zero trust, is what's given us the solid foundation to build these walls on. So what does this mean for RabbitMQ? So why am I talking about zero trust and we're at a RabbitMQ summit? Right? Well, essentially, the threats that we're facing today, they're affecting everything that we touch, right? So if you're using any kind of messaging system to build a banking app or look after medical records or anything like that, then you're going to have to start thinking about your core business value, your data, and how you're going to protect these things there. So when we think about RabbitMQ, every credential that you issue to an application for it to access RabbitMQ is essentially an application identity. Right? Remember what we said in the beginning is that we can verify the identity of a person or a workload by a unique piece of information. So when we give it that credential, we're giving it an identity. This identity should not be shared amongst multiple applications. I've done a lot of consulting over the years and I've seen this practice where the same password or the same piece of information is used across multiple things. Essentially, they're sharing the same identity. And why this is bad is if you do experience a breach of some sort, you're always looking for these breadcrumbs to try and trace how it happened so that you can mitigate the impact that it's had. Now, if it could have come from 4 or 5 different places as opposed to the one place, then your job is a lot harder, plus your attack surface is a lot bigger, right? So when you take this singular approach where one application, one credential, one identity, right, it means that access controls can be more fine-grained. So if we have a specific service in our stack and it only needs to perform certain functions, the access controls we put in place can be very granular and say, this is all it can do. It cannot do this, it cannot do that, it can only do this thing here. Rather than creating a credential which has more access than it should do, and then multiple applications are using it just because they need to do different things, right? So as your application grows and scales, you can see how one application, one identity can start to become a management overhead and a nightmare, frankly, right? If you've got 10 services in your stack, well, that's just 10 identities, but then you grow to 100, 1,000, 10,000. You have to manage all these things. These things are tied to the life cycle of your applications. So if you need to retire an application, you need to remember to retire that identity. Because if you don't, and someone gets hold of that, they're able to get into your system and do whatever it is that that service was permitted to do, right? So we're talking about managing the life cycle of our application, which is a manual process, and it's also prone to human errors as well. We are human, we do make mistakes, right? So what about the application data that is placed on the message queue, right? How do we protect the confidentiality of that sensitive data in this case, right? And the simple answer is pretty much to encrypt the sensitive data before we put it on the queue. The problem with that is cryptography, if anyone has tried to implement it themselves, is nothing. It's nothing like simple. It's very complicated, right? implementing cryptography by itself, it has its own challenges. There are things that you need to solve and complexities you need to overcome. Like, for example, how do you securely store and manage the lifecycle of your cryptographic keys? That will be your problem if you are implementing these things yourself, right? How do you govern access to these keys? How do you know who's accessed this key, who's used this key to decrypt data, who's done this, who's done that, right? This is a very tedious process, and it has multiple layers to it, and it's very, very error-prone. So how can HashiCorp Vault help with this, right? So I guess it depends on what Vault is to you, right? If anyone hasn't heard of Vault, let's just have a quick rundown of what some people think it is. So to some people, myself included when I first got into this space, I saw Vault as a secrets management platform. I saw it as a place where we can take our long-lived credentials. So we'd say, for example, in RabbitMQ, we generate a credential and we would store it in something like Vault so that our applications would go to Vault and grab this thing when it needed to access RabbitMQ. So it was just a secrets management platform, a store, pretty much, right? But then Vault started bringing in things like ephemeral secrets, right? So what we mean by this is instead of storing long-term passwords like the example I've just given, instead what happens is when an application or a human needs a credential, they go to Vault and say, hey, can I have an identity for this platform? And as long as I'm authorized to have an identity, it will generate a short-lived credential, right? So it could say a TTL of 60 seconds, for example, which is unpractical. So it would go to RabbitMQ, it would create this identity, and it would give me the username and the password. Once that TTL has expired, then it would go back to RabbitMQ and remove the identity. So when Vault is doing that, you can start to think of it as an identity broker, right? RabbitMQ is just one of many platforms that it will do it for. And I'm guessing there are other secrets management platforms out there which are brokering identity in a similar way. Right? The other thing that Vault can do for us is it can take care of the cryptographic side of things for us, right? So it provides encryption as a service. Now, essentially what it's doing is it's managing the lifecycle of the keys. It's giving you good audit information about access to those keys. You can now put granular permissions as to what actions can be performed with these keys, whether it's encryption, decryption, HMACking, signature verification, all these types of things here. All the complexity of managing cryptographic actions is all managed by Vault. And that's kind of what we want to do these days. Our lives are complicated enough as it is. We want to offset the most complex problems to systems which are really good at doing that. And we'll focus on what we're good at, right? So when you put all these things together, what is HashiCorp Vault? Well, like I say, to people, it's a secrets management platform. To others, it's an identity broker. For other people, it's cryptography as a service. To me, it's a standard security library. You know, just like Kubernetes has become a standard security library for infrastructure. And I think the thing that makes Vault really developer-friendly is everything is API-driven, right? So anything you can do on the command line, you can definitely do in the API. They build the API first, and everything is centered around that. And that's the point, is developers, we understand how to interact with APIs. It's our bread and butter, right? So if you're going to build a security system and you want developers to be able to utilize the value from it, you need to meet developers where they are, which is kind of APIs is the universal way to go. So we're at the point where I'm going to pray to the demo gods. This was working before. I've had to restart my machine, so I really hope that we're able to get this demo working. But I'll walk you through what we're about to do, right? So to demonstrate Vault in action with RabbitMQ, what we're going to do is we're going to refactor a very simple Go application, right? One service is going to be a message producer. Another service is going to be a message consumer. Each service is going to obtain a short-lived credential from RabbitMQ from Vault. And additionally, the producer is going to encrypt its message, its data, and the consumer is going to decrypt it. And the way that this is going to work is the producer is only going to have the permissions to perform encryption actions, right? It's not going to be able to decrypt anything. And the consumer is only going to be able to decrypt using this specific key. It's not going to be able to encrypt anything or HMAC or do any other cryptographic actions, right? And before we get into this, I'm going to make the point before you see the code that this is just a demo application to demonstrate a workflow. I've written it in a very verbose way because I'm trying to demonstrate the steps that are happening under the hood. It's definitely not optimized for high throughput or performance. I'm guessing people in this room are going to be a lot more skilled at me than writing applications like this. But I think for you to implement this into your workflow, you need to understand the verbose actions that are happening under the hood. So essentially, you may have questions like, oh, what's the latency on this? And how is it going to affect the speed of your application? These are all valid questions, and the demo I've got today is not here to give you any confidence on that front. There are things that we can do to address those questions there, but that's not a conversation for today's demo. So I need to stop sharing my screen so I can get my code editor up. And right, and we will share screen again. We share desktop one. And then we'll just move over to my code editor. And we can see that, yes. Okay, cool. So, like I said, the demo gods were messing with me a little bit earlier on. So when I got my computer back up, I already got Vault running. I've already got RabbitMQ running locally on my machine. I don't know if anyone's aware, but we actually have a Terraform provider for RabbitMQ, which is really cool. You can pretty much manage all of your RabbitMQ resources with that. So we'll just have a quick look at the Terraform code just to show you what I have done, just so you can understand what's happening under the hood. So what we've done firstly is we've created a user in RabbitMQ for Vault. So Vault is going to need an identity in RabbitMQ to manage identity on behalf of RabbitMQ, essentially, right? And you wouldn't want to give it the main administrator account. So we've just created a Vault user here, and we've assigned these permissions here as well, right? We've also created a vhost and an exchange, just for the demo purposes. We didn't want to use the default one. And I think that's it. That's pretty much what we've done in RabbitMQ. Now, if we look at Vault, and we look at some of the resources here, we have firstly created a secret backend in Vault. So what the secret backend is doing is the whole identity brokerage side of things, right? So this is what's going to be able to connect to RabbitMQ and create and manage and delete identities on behalf of RabbitMQ. So we're just giving it the connection URL, and we're giving it the username and password of that user that we've just created in RabbitMQ, right? And then what we want to do is we need to create roles, right? So it's going to create users in RabbitMQ, but what RabbitMQ permissions are these users going to have, right? So we create roles to kind of represent the access controls within RabbitMQ. So we have a role called producer, which is going to have the permissions on that vhost that the producer is going to require to perform its actions, and nothing more, right? But the consumer is going to need a different set of permissions within RabbitMQ. So it's creating another role within Vault where it will be able to create identities using that role, and it will have those permissions there, right? And then what we've done is we've got some Vault policies here, right? So essentially, if Vault is going to be acting as the identity broker for RabbitMQ, our applications are then going to have to access Vault instead, right? So that's going to be our centralized secrets management platform, our centralized identity broker, our centralized security everything, right? So when our producer logs in, what is the producer authorized to do with Vault? Now, the good thing about Vault is everything is path-based. So I said that we're based around APIs. So you normally have your URL, and you have a path that follows the main endpoint. So the way that we do our permission structure is exactly the same as how you would write the URL for your API, right? So we literally have RabbitMQ creds producer, and this is the path that we're going to use to generate some credentials for our application, right? The other permission we've put inside this producer policy here is the permission to encrypt data using a cryptographic key called RabbitMQ Summit. So it can't do anything else but those two things. It can grab some credentials under the producer role for RabbitMQ, and then it can use a key called RabbitMQ Summit to encrypt data. we have another policy which is similar, but this time it's for the consumer. So the same things, but this time it's grabbing a consumer credential from RabbitMQ, so it's only going to have the consumer credentials. And the cryptographic action that this identity will be authorized to perform is to decrypt data. So that's the main difference between those two policies there, right? So if I just flick to browser here, and we do the good old trusted guest, which I'm sure you're all familiar with. If we go over to the admin side of things, we can see that there's the Vault user that we created and obviously the guest user that I've just logged in with, right? So essentially, if I just go to the command line here, let's move this out of the way, and you can see I ran a command earlier on to create a token, a Vault token, with the RabbitMQ consumer policy attached. It's giving me that token, and that's what I'm going to give to the application. There are actually much nicer ways to get your application to authenticate with Vault. I've just done it like this for simplicity reasons, just to demonstrate what's going on under the hood, right? And what will happen then is it will create this identity. If I actually just run this command again, we should see it create another token, which you can see that identity there. So it's oh, sorry, I'm typing the wrong. That's the token. That's what we're given to the actual application. If I then do, let's say, Vault read, and then the path is going to be RabbitMQ, and we want some creds, and the role will be consumer. If I run that command there, it gives us a username and a password for RabbitMQ, right? If you head over here, you can see there's now an additional identity that has been added to RabbitMQ. The way that the lease is set up on this is the TTL is 768 hours, so it's not going to delete anytime soon. But if for whatever reason we need to revoke that identity, we can easily do so. We'll just do Vault lease revoke, and we just want to give it the lease ID, which you can see it gives you this here, right? So if I do that, run that, it queues a revocation. If you give it a few seconds, then you'll see it's disappeared from RabbitMQ. So that's me manually revoking the identity, but the idea is when the TTL expires, it will go and do that action automatically for us, right? So this is what we want to build into our applications. We essentially want to do that. So if we look at the, let's take a look at the consumer package. If we go to our main.go, I'm not sure if people are familiar here with Go, but I'll just walk you through what it's doing. The syntax isn't important. What's important here is the workflow. So you can see on screen here something very bad. You can see that we've got on line 17 the URL to connect, the connection string to connect to our RabbitMQ instance, and it's got the username and password in there, right? Now, bad practice, obviously, you don't want to put the credentials within your code. People are probably using config maps and or other means to inject these credentials in. But the challenge here is it's still long-lived credentials. So if that credential is leaked somewhere, anyone can do the things that this is authorized to do. So essentially, the first thing we want to do is we want to remove that credential there, and we want to now tell it, actually, no, go to Vault and get the credentials from there, right? So we can refactor this a little bit, but before I do that, I just want to run this service. So if I do go run, okay, we just run the service, and all it's doing is it's now, what's it saying here? It's not found the queue. Oh, I know why. Don't worry. I've messed up my demo because my computer restarted. Please forgive me. We'll clear that. We'll go to the producer, is probably the easier way to do it. So if we go to the producer and we do, let's just check the producer code. And literally, all this is going to do is going to publish a message to the queue saying RabbitMQ Summit London 2022. So if I just do a go run, and hopefully I don't get any issues with this. That's not a good sign. Oh, it is a good sign. So it's published a message to the queue, right? So we go back to our consumer. And if we go to the main.go, now we've run that, we should have everything in place. If I run this again, hopefully we don't have any issues. That's looking good. If I go to my producer again and run that again, we should see, let me see if I can actually set up a terminal side by side. So actually, if we just run this, we should see that the message has now been received in there. It's all in plain text, and we haven't done anything to secure this application. So first thing we'll do is if we just go to our consumer, and we'll get rid of this line here. So we'll comment this line out. And essentially, we now want to structure our connection string ourselves, and it's going to be using this little piece of code here, right? Now, all this code is doing is it is using a small function that I've written to generate some RabbitMQ functions. So we can have a quick look at that. It's called creds generator, right? So we just have a couple of structs here, which is just like classes in any other programming language. And it's just making API calls, right? Essentially, we're looking for environment variables for the address of Vault. We're looking for an environment variable for the token of Vault. And we're making an API call to Vault to say, hey, this is my token, give me a RabbitMQ credential. Simple as that, right? So if we go back to our main.go, we're now using that function we've just written. I'm not quite sure where that's coming up as undeclared name, but it should work, fingers crossed. And then, yeah, it should be able to just run again. So if I save that, if I kill my, my listener for the consumer, and then I run again, that should just start listening again. But this time, it's listening using generated credentials from Vault, right? So if I go back to my producer and run that again, which is still using the hard-coded credentials in the producer, the consumer has now got another message saying RabbitMQ London, right? So we'll just quickly refactor our producer doing the same things, right? Again, I've told you, this is very verbose. I've repeated code in certain places just to demonstrate exactly what I am doing. You would probably write this in a more efficient manner if you were doing this for yourself. So if you go to this main.go, we will just uncomment that. We will comment this out because we don't want the hard-coded credential in there. And we'll uncomment that, so it's just going to restructure it's going to actually change how it's getting that credential. And then if we head over to our producer and run that again, we should hopefully not have any problems. And that looks okay. We'll go to our consumer, and you'll see we have another one, right? So that's the whole identity piece sorted out. Now let's talk about the security of our data itself, right? So we have this message in here, which is RabbitMQ Summit London. It's all in plain text. Anyone that has access to that queue will be able to get this piece of data. So if that were a credit card number, you'd be able to see that, right? So essentially what we want to do is we want to use this other function that I've written, which is message encryptor. And again, it's doing a similar thing to what the RabbitMQ credential generator was doing. It's making an API call to Vault. Simple as that, right? So we're literally going to pass it an argument from the command line, which is going to be our message. It's going to do the same things where it gets the environment variable for the Vault address, it gets the environment variable for the Vault token. And then we need to give it a payload, right? So the payload is going to be the message that's going on the RabbitMQ system. And the way Vault requires this payload is it has to be base64 encoded, right? So we're going to take this and we're going to base64 encode it. And that should really be it, right? So essentially, if we go back to our main.go, we can do a short refactor here. So we can uncomment this. I didn't trust myself to write this code out from scratch. So I just wrote it in and commented it out, right? And we'll comment that out. And I've messed up here, haven't I? Oh, no, I haven't. Oh, that's all good. That's cool. We'll save that. And now, when we run our producer, sorry, sir, what's your name?
Lincoln.
How do you spell that? How do you spell it?
V-E-N-K-T, Venkat.
V-A?
V-E-N.
Yep.
K-A-T.
K-A-T, Venkat. Good to meet you, Venkat. So that's going to be our message on our message queue, right? But the trick is we shouldn't be able to see your name. That's sensitive. That's personally identifiable information. So hopefully the consumer can't see that because we haven't done anything on the consumer side. So we run that. If we go to the consumer side, it's encrypted. Right? So you can see that you have a Vault, as it's telling you that it's Vault that's done the encryption. The version 1, is the version of your cryptographic key. Now, if you were to rotate that key, you'd have version 2, and you can rewrap your data and so on and so forth. But we've only got one version of that key, right? And then you just have some ciphertext. This is all the ciphertext is, right? So if we then go to our consumer, and same thing, I've written another function here, which is message decryptor. I don't really need to go through that because it's just the same as the encryptor, just the opposite. So we're going to do that short refactor here, where it's going to decrypt the message when it consumes it, right? So we'll just uncomment that, and we'll comment this out. Okay, run that, and then if we stop and restart our consumer service, hopefully we won't get any issues. Doesn't look like it. Now, Venkat, now we should be able to see your name, because you know why? The consumer is authorized to know your name to perform its function, right? So if we run it again, and then we go to our consumer, it's decrypted it. So now what we've got is that symmetric decryption, right? So each service only has the permissions that it is authorized to do, right? And it doesn't have anything more. This consumer cannot go and encrypt data. The producer cannot go and decrypt data. It doesn't have any business reading credit card numbers or something from something else that it doesn't need. And this is the value of how you can use just an API. Everything you've seen is just for an API. You can do this exact same workflow in any language. There are SDKs out there. I prefer to use the API because everyone understands API documentation, when it's well written, that is. And yeah, that's pretty much what I wanted to show you today. So you can increase the security posture of your applications using these things here. I would encourage you, if you are going to implement something like this, to experiment with different system patterns, experiment with how you're going to get the best performance out of this. You know, I don't want to quote benchmark numbers, because there are so many different variables in benchmarks. You know, like if other people are using the same Vault for other secrets management things, that's going to have an impact on performance and so on and so forth. Some customers have done 50,000 requests per second. Some have done 200,000 requests per second, but they've done very specific things to make their Vault clusters operate in a certain way. So if this is something that's interesting to you and you want to speak to me about potentially what a benchmark looks like for your use case, this is a really interesting conversation for me. But that's what I wanted to show you today. I just wanted to try and get you thinking about ways that you can start to increase your security posture about your applications. So I really do hope you found that useful and enjoyable, and that's been my time. I'm Rob Barnes.